So we continue with the resonance part, and now we see the third example or the third experiment to show that how the resonance would take place in the air column. So the next one is, now this particular, the experiment 2, which was about the 4 pendulum, and the experiment 3, which is about the air column in the tuning fork, are the experiments which they have asked many times in boards as well as prelim for a 5-mark question, or at least 3-4 mark question, where they will tell you that what are the changes you will find over here, what are the changes you will see over here. So that's why just go through that particular experiment properly with the observations and all, that what is required. Now the next one is the experiment in which you are taking a two containers. So one is this test tube like a thing, but it is connected to a tube, and that is going to be connected to a another kind of a tank or a container. Now of course water seeks its own level, so water over here will be equal to the water level over here, so this will be the same water level. Okay, what you are going to do is bring a tuning fork. So a tuning fork is going to be hit and brought near this. So this is under vibration and going to be brought over here, and then you are going to go and make it up and down and see what happens to the sound. So let's see. So resonance in air column. Figure 7.1 shows an arrangement for the study of resonance in an air column. It consists of a long cylindrical tube A and a cylindrical vessel B. The tube A is fixed, while the vessel B can be moved up or down, and it can be clamped at a desired position. Both the tube and the vessel are connected at their lower ends by a rubber tube, and they are partially filled with water. The movable vessel B serves as a reservoir. So you can easily say this is the reservoir, and this is going to be in a stand. Of course, this will be connected to a stand like this. So this is fixed. But this one over here, the stand over here, will be such that you can move this up and down. So you can move this up and down. With the moving it up and down, what will happen? The level of the water over here will keep on increasing and decreasing. So अगर मैं इसको ऊपर लिया, तो automatically ये जो है वो नीचे, it means it will be such that if I bring it up, so this will go down, and if you are giving it down, it will go up. So depending upon how I go, the water is going to seek its own level. So अगर मैंने tank का पानी ऊपर कर दिया, तो automatically more water will be there on the this side. So more water will be here, and it will be filling it more in this when it brought upwards or downwards. So सबसे you are trying to manage to see to it that you are increasing, or you can see, simple thing is that by making this up and down, you are increasing or decreasing the air column which is present inside the tube. Okay, that is what we are trying to understand. Right, so the movable vessel B serves as a reservoir. The tube A serves as a closed end air pipe with water surface in it forming the closed end. That is the reflecting surface of the sound. So sound is going to get hit over here, reflect over here. So that is what is the sound is going to be produced. Thus an air column is formed in the tube A between the water surface and its mouth. So here, this is the air column. This particular part is the air column which is going to be there in this particular tube. The natural frequency of the vibration of the air depends upon its length. That is, frequency is inversely proportional to the length. So F is proportional. We know that F is proportional to 1 upon L. Now this we had seen it when we are talking about the frequencies earlier. So frequency was dependent upon, in the air column, जैसे वो flute में था, right? The flute में 1:2:3 for both sides open, one end closed will be 1:3:5. So there's the same thing over here. It is here one end closed, so it should be 1:3:5. Okay, so we see over here that By moving the reservoir up and down, thus an air column is formed in the tube A, thus the water surface and its mouth. The natural frequency of the vibration of the air depends on its length, since frequency is proportional to 1 upon L. By moving the reservoir up and down, the length of the air column in the A can be changed, due to which the natural frequency of the air column of the tube A changes. So, you can change the natural frequency of the tube A because you can change the amount of air present in the tube A. If the air is less or more, depending upon the length, you are changing the natural frequency of the tube. While performing the experiment, the tube A is first filled with water up to the top. Then a vibrating tuning fork is placed just above the mouth of the tube A, and level of the water in it is gradually lowered. So what you first do is you bring this reservoir upward so that iska water level jo hai wo yahan tak aa jaye. So the water will be up to this point, and then you hit the tuning fork and bring it near, and then slowly gradually put it down so that this level also goes down. So as you bring it down, so the air column is 0, and then you are keeping on increasing the air column as you move this thing. This also air column keeps on increasing. Observation: a loud sound is heard at certain level of water. On further lowering the level of water in tube A, the loud sound ceases. But when the level of the length of the air column in the tube becomes 3 times the previous one, the loud sound is heard again. So what is the observation? The observation will be, suppose at 10 millimeter. Suppose at 10 millimeter, if I am able to hear a loud sound, 11 millimeters पे वो loud sound चला जाएगा, 12, 13, 14 वहाँ पे भी loud sound नहीं आएगा. But as soon as it becomes 30 millimeters, again I will hear a loud sound. Then again 31, 32 I will not see any loud sound. But then again when it becomes 50 centimeters, I will see again hear a loud sound. So periodically at 10, 30, 50, ऐसे करके 70, वैसे मुझे अलग अलग distances और अलग अलग air column के height से हिसाब से I am going to get the different hearings of the air column. So hearing of the loud sound. So explanation to this thing is this way. The vibrating tuning fork held just above the mouth of a tube A produces force vibration in the air column of tube A. When the frequency of the air column is decreased by increasing the length of the air column, when the frequency of the air column, so when the frequency will be, now we know the frequency is directly inversely proportional to the length. So if I increase the length, automatically the frequency is going to decrease. So when the frequency of the air column is decreased by increasing the length of the air column, or that is by lowering the water in the tube, a certain level of water in tube A, a loud sound is heard. So at a particular point of this air column, okay, when the air column becomes a particular level, at that point it is equal to the natural frequency of the body, और जब भी वो natural frequency पे आया तो resonance हुआ, यानी loud sound is going to be heard. So at a certain level of the water in tube, a loud sound is heard. This happens when the natural frequency of the air column becomes equal to the frequency of the tuning fork. So when the natural frequency of the air column and that of the tuning fork becomes equal, at that time a loud sound is going to be heard. That is, the vibration of the air column are in resonance with those of the fork. On further lowering the water in the tube A, the frequency of the air column does not remain equal to the frequency of the fork, so the loud sound ceases. But on further lowering, the level of the water or stage is again reached when the loud sound is heard. At this stage, the frequency again becomes equal to the frequency of the loud tuning fork when the length of the column becomes 3 times the previous length. So the resonance occurs again. So you can see the resonance is going to occur with the vibration in the radiation of 1:3:5. So पहले अगर 1 पे आया तो फिर again 3 times the length, you are going to get it 5 times the length, again you are going to get it 7 times the length, you are going to get it again. So this way the frequency is going to be hitting the resonant frequency and the ratio 1:3:5. So that is what they are given in the star, the blue colored thing at the bottom of the page, that though in an air column of given length with one end closed, the frequency of different mode of vibration are in the ratio 1:3:5. But if length of the air column with one end closed is tripled, the frequency of vibration of air remains the same because the wavelength remains the same. So, okay, that is not required, or you need not worry about this because they are talking about the wavelength. We are not talking about the length of the air column is triple. The frequency of the vibration of the air column remains the same because the wavelength remains the same. So that is a different thing. Wavelength is the same because V is equals to F lambda. So that's why if length is made to be 3L, then automatically it will be wavelength is going to be F1 is equals to V upon 2L1, then F2 will be 3V upon 2L1, so it's going to be the same. So it doesn't matter, you need not worry about that star mark. If you not understood it, doesn't matter because there's nothing connected to your portion. So only thing what you need to know is that it will be in the ratio of the frequency will be or the loud sound will be heard will at the 1:3:5. So yeah, so if you've seen that at this state the frequency of the air column becomes equal to the frequency of tuning fork when the length of the air column becomes 3 times the previous length. So now we differentiate between the force vibration and resonant vibration. Force vibration, the vibration of the body under external periodic force of vibration frequency different from the natural frequency of the body are called as the force vibration, whereas the resonant frequency is the vibration of the body under external periodic force of frequency exactly equal to the natural frequency of the body are called as resonant vibrations. Force vibration, the amplitude of vibration is small. Resonant vibration, the amplitude of vibration is very large. Force vibration, the vibration of the body are not in phase with the external periodic force. Resonant vibration, the vibration of the body are in phase with the external periodic force. And finally, force vibration, these vibrations last for a very small time after the periodic force are ceased to act. Whereas the resonant field, these vibrations last for a long time after the periodic force has ceased to act. So this is about the force vibration and resonant vibration. Now we see certain examples of the resonance in our day-to-day life. Okay, so let's see one by one. Resonant vibration of pendulum. As discussed earlier in experiment 2, if two pendulums of same length are suspended from a rubber string and one pendulum is made to vibrate, the other pendulum also starts vibrating with a larger amplitude and in phase, same phase because of resonance. So that is about the pendulum. अगर दो pendulum को अगर हम लोग ने rubber string के साथ connect किया, तो इसका maximum जब भी होगा तब इसका minimum होगा, फिर इसका maximum, इसका minimum होगा, and they will keep on in sync with each other or in phase with each other. Resonance in machine parts. When a vehicle is driven, the piston of the engine makes a to and fro motion of the at a frequency depending upon the speed of the vehicle. The vibration caused by the movement of the piston are communicated to all parts of the vehicle. It is just possible that at a certain speed of a vehicle, some part or frame of the vehicle may have natural frequency of the vibration equal to the frequency of the to and fro movement of the piston. At this particular speed of vehicle, that particular part of frame starts vibrating vigorously due to resonance and a rattling sound is heard. If this part is not tightly fixed, such vibration may cause the part to drop out. To stop these vibrations, the speed of the vehicle is changed so that the condition of the resonance does not hold. Thus, resonance can occur in all kinds of machines while operating in a particular condition. This is very, very common in our day-to-day life. You must have seen that whenever you are traveling in some kind of a not so good condition car or a bus or a van, school van or something, you will find that at a particular speed there will be a rattling sound of either the window cut करके आवाज आता है या तो some screw का वो आवाज आता है, तो there will be continuously some rattling sound which will be continuously given. Like even in the lift of my building itself, when we are using the lift को जैसे तो ऊपर का जो fan का area है, that will continuously start vibrating and give you a particular loud sound. So that is because that the vibrations which are there in the machine. See, the motor of the lift or the motor of the engine of the vehicle is continuously in motion and it is having its own frequency. If that frequency, frequency it is dependent on the speed at which it is traveling. So वो स्पीड अगर एक पर्टिकुलर पॉइंट पे आया कि जहां पे उसका स्पीड यानी इंजन का स्पीड एंड द स्पीड ऑफ एनी पर्टिकुलर एंड द फ्रीक्वेंसी ऑफ एनी पर्टिकुलर लूज पीस ऑफ द मशीन, लाइक फॉर एग्जांपल द window of the sliding window of a particular bus or a screw somewhere or some kind of a plate or somewhere in a bus or on a van or any car, or या तो जैसे लिफ्ट में बताया. So when that is equal, they will start vibrating with a resonant frequency and produce a loud sound. So this can be avoided either by increasing or decreasing the speed. So if I increase or decrease the speed, automatically it is not going to remain in the resonant frequency and hence the sound will not come. Or else of course it needs to be tightened up. So अगर वो loose है उसको tight कर दिया तो भी वो अपने आप उसका frequency को हम लोग ने block कर दिया. So this is how the resonance is going to be. So accordingly, resonance can occur in any of the moving part or any part of the machine. So when it is operating, though any part of the machine can be under or resonant vibration. Third is the resonance in a stretched string in a sound box of musical instrument and sonometer. A vibrating string by itself produces a very weak sound which cannot be heard at a distance. Therefore, all musical string instruments such as a guitar and a sonometer are provided with a sound box or hollow chamber. The box is also constructed that the column of the air inside it has a natural frequency which is same as that of the string stretched on it. So it is so well made that you can it's not that you take any dabba and put it over there and it becomes the guitar. No, it will not be so. So the sound will be very nice when the frequency of the string and the frequency or the natural frequency of the string and the frequency of the air column inside of the guitar is going to be the same. And when that happens, the air column will always be under resonance. So a very small plugging of the guitar strings will give you a very nice sound. So that particular thing is going to be seen in case of string instruments, where the box is constructed that the column of the air inside it has a natural frequency which is same as the string stretched on it, so that when the string is made to vibrate, the air column inside the box is set into forced vibration, the frequency of which is same as that of the string. Since the sound box has a large area, it sets a large volume of air into vibration, so due to resonance a loud sound is heard. So a small plug inside on the strings of the guitar produces a loud sound because of this particular thing, that the strings which are there in the guitar and the sound box which is there on the guitar, they have got the same frequency or the same natural frequency. Fourth, resonance in air column and tuning fork. As described in experiment 3, when the frequency of the air column becomes equal to the frequency, that's the same thing, frequency of the air column becomes equal to the frequency of the tuning fork vibrating over its mouth, a loud sound is heard due to resonance. Third, now this is very important, that is resonance in a bridge. Now, the army, when they are traveling from one place to another place, they need to go through rope bridges. Okay, the rope bridges are such that they will be always suspended bridges. Okay, now when the army is asked to move from one end to another end, they are told not to do any march pass on that. So they were told to break the steps. What do you mean by break the steps? And everybody should not step on the bridge simultaneously. You know, normally whenever the army is walking, you'll find it's left, right, left, left, right, left. यानी क्या होता है? Every time जब इसका सब लोग का left एक साथ में गिरता है, सब लोग का right एक साथ में गिरता है, so there will be a kind of a force vibration which could be the resonant vibration of the bridge. So what they do is they are asked to break the steps. When they break the steps, यानी क्या? अगर एक का left हुआ तो दूसरे का पैर भी ऊपर रहेगा. जाएगा तभी वो नीचे नहीं रहेगा, एंड जब भी उसने लाइट लिया यानी बेसिकली एवरीबडी इज नॉट स्टेपिंग देयर स्टेप ऑन दी एट द सेम टाइम, यू नो एक का स्टेप आया तो दूसरे का स्टेप बाद में आएगा फिर तीसरे का आएगा, सो दैट इज नॉट लाइक एवरी टाइम एवरीबडी इज गोइंग टू बी एट द रिदमिक थिंग, यू आर ब्रेकिंग द रिदम विथ व्हिच द foot are going to be hitting the bridge so that the bridge does not reach the force vibration equal to the resonant vibration. So क्योंकि अगर resonant vibration हुआ then the bridge will start vibrating and it will even collapse. So that's why it is seen that the troops are always told to break their steps when they are passing through a rope bridge. So that's it. When a troop crosses a suspension bridge, the soldiers are asked to break their steps. The reason is that when soldiers march in steps, each soldier exerts a periodic force in same phase and therefore the bridge executes the force vibration or frequency equal to the frequency of their steps. So सब लोग ने एक साथ में ठम 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 किया तो क्या होगा, सब लोग का एक साथ में वाइब्रेशन आएगा, so वो नहीं चाहिए, that's why they are asked to break the steps. Now if the frequency of the steps become equal to the natural frequency of the bridge will vibrate with larger amplitude due to resonance and the suspension bridge may collapse. So that's the thing that if the steps ka jo frequency hai, the frequency which the steps are hitting the bridge and the natural frequency of the bridge is the same, so then will be resonance and accordingly the bridge will be in resonance, so amplitude will be very large and it could break, collapse. The sixth one is the resonance in radio and television receiver, TV receivers, television receivers. The tuning of the radio and TV receivers is based on resonance. The radio and TV receivers have electronic circuits which produce electromagnetic vibrations, the frequency of which are changed by changing the values of the electronic component, either the capacity of condenser or the inductance of the coil. When we want to tune a radio or TV receiver, we merely adjust the values of the electronic component to produce vibration of frequency equal to that of the radio waves which we want to receive. When both the frequencies match, resonance occurs and only the energy of signal of that of particular frequency is received from the wave present in the space, leaving the signals of other frequencies which do not match with the frequency of the receiver circuit, the signal received in them amplified in the receiver's set. Okay, what do you mean by this? Whenever we want to listen to a radio, see television में ज़्यादा हम लोग को पता नहीं चलता because you don't set it exactly on the frequency base because it is automatic, you know, you just put it on the auto search and it searches everything and just stores it. But when we're talking about radio, we very well know that okay, I want to listen to 91.1 or 94.3. तो वो जब भी मैं 94.3. So what is that? That is the frequency at which the transmitter is transmitting the waves. Okay, the transmitter, the radio transmitter is transmitting the waves at a particular frequency. So in the space, all the frequencies are available. Okay, the frequency of 91.1, 91.3, 98.3, 104.4, 104.8 अगर जो भी है वो different सभी के सभी frequencies space में available है. If I tune my receiver, so okay, my radio set, if I tune it exactly to 91.1, at that time what will happen? The sender and receiver का जो है वो एक resonance में आ जाएगा because the frequency of my radio set and the frequency of the incoming the waves is the same, so they are at resonance, and because of that a loud sound of that particular thing is heard. The others are present but because they are of frequency not the same, that's why there is no as resonance and hence I am not able to listen to them properly. And you can see that अगर मैंने 91.1 के बदले 91.05 भी कर दिया या 91.15 भी कर दिया, I will not be able to hear to that particular radio properly. There will be disturbances in that particular radio set transmission because the resonance has not matched. It will be a loud sound heard, a proper loud sound will be heard, or a proper television screen will be seen, or the without distortion, the thing will be there only if the frequency of the sender and the receiver is the same, and there is a resonance which is going to be there between the sender and the receiver. Only then the receiver will be able to hear the thing what the sender is sent in the exact form. So that's what they are saying, that when both the frequencies match, resonance occurs and only the energy of signal of that particular frequency is received from the waves present in the space, leaving the signals of the other frequencies which do not match with the frequency of the receiver circuit. The signal received is then amplified in the receiver set. So of course whatever signal is going to be amplified so that you can hear it properly on the stereo system. So that is how the resonance is being used in radio set and television set. So that is about the examples of resonance. So this was the end of the second part of the chapter about resonance, and the third part of the chapter is based on characteristics of sound and their subjective and objective nature. So that is about the part of loudness, pitch and quality or timbre of the sound. So that is this part. Now out of this part, certain parts of this particular part, that is the sound subjective and objective property में से बहुत कुछ cancelled हुआ है as per the new syllabus of the 2020. In 2020, because of the reduction in the syllabus, certain things are cancelled. So the things which are cancelled will be measured about the subjective and objective property of the nature, and also about the relationship of the loudness and intensity का जो part है. So that part is not there. So we will just go to the other parts of the chapter, but I think with the next video. So that is about end for this particular video.